Hyperbola, hyperbola, hyperbola. Well, hyperbola is different. Not totally, but it's different. Number one, have two branch. So we have two kinds of hyperbola. Okay, one hyperbola que I call horizontal, like that. Another hyperbola que es vertical, it's like that. The most important is understand in what direction is the transversal axis. And what is that? This is transversal axis, look. In this case, coincident with the x-axis, but not always. It's coincident or parallel to the x-axis. In this case, no. The transversal axis is this. Coincident or parallel to the y-axis. Okay, this is transversal. Identification transversal. How you identification? Well, you identification by the equation. The equation is x squared over a squared minus y squared over b squared. Remember the hyperbola, we have x and y squared, but the sign between them is negative. It's the clue of the identification. Remember, ellipse, both are square and positive. Parabola, no. Parabola, one square, another no square, or like that. This is parabola. And hyperbola is x squared and y squared is both square but minus. This is the clue of the identification. But in this case, you see that the positive part, que es this, is associated with the x. That means que the transversal as lie or es parallel to the x-axis. In this case, no. In this case, it's y squared over a squared minus x squared over b squared. Okay, well, you see that the negative part is in x and the positive part is important. It's associated with the y. That means that the transversal axis is parallel or lie on the y-axis. Entonces you see maybe something weird, professor, pero I see weird. Que who is A, who is B? Oh, okay. And the ellipse, don't confuse it, it's different idea. And the ellipse A is the major axis and B minor. No, in this case we have no major, no minor. No. A is associated always with the positive part. Okay? A is always associated with the positive part. It doesn't matter if it's X or it's Y. And B is the another guy. Okay? So what is the most important parameter in the hyperbola? This is the identification. Nice to meet you. The most important identification. Suppose that we have horizontal to explain one case. Very case similar. Suppose that our hyperbola is like that. And we have the famous point. What is the famous point? The most important point is the center. Center. You assume que 0,0 in this equation, but in general, no. In general, it's x minus h squared over a squared minus y minus k squared over b squared equal 1. In this case, the center is located at the point h, k. When you have motion, when you have transformation. So you have no transformation, this equation is 0, 0 because h is 0 and k is 0. Center. Next is the vertex in plural, similar to the ellipse. It's this guy and this guy. And this is the distance here is 8. No repair. The distance is 8. Look, that distance is 8. That distance is 8. Entonces, si you know the the point of the center when you are adding A and subtracting A and the X component, no? And the focus C, foci, because there are two foci, similar to the elixir foci. The distance is C. Always the focal distance is C, and C is the distance. Look, from the center to any point, but inside here. This is a focus 1. And this distance I put in blue color is C. And this distance is also C. It's another focus 2. It's obvious que always happen que C is bigger than A. Okay? And the formula que state the relationship between ABC is C squared is equal to A squared plus B squared. U identification super easy A because A is the number associated with the positive part, and C is the distant focus, and B no. B geometrically B is different. Let me try to explain the idea behind B. The hyperbola have two oblique asymptotes like that. It's the same line. Es obvio que the curve en red color approach pero never touch. This is a slant asymptote. And this is another slant asymptote. And the formula for this is y equal plus or minus b over a x. Well, the supposition is que the center is in 0,0, this formula, no? And we have two lines, and one line is using positive slope, okay, of course is this. Asymptote 1 is positive slope, asymptote 2 is negative slope. It's the same value, but plus or minus. In the general case, que the center is no 0,0, is h, k, one of the formulas for the asymptote is y equal, or no y equal. The classical way to express is y minus k is equal plus or minus b over a parenthesis x minus h. Because the supposition is the center is at the point h, k. You know, h is always associated with the component x and k is always associated with the component y. Okay. Entonces, what is b? I don't see b. B is to make the asymptote, we need to control one reference rectangle. Que is this guy? Like a box. And this distance in the box is b. Therefore, the slope is right over wrong is b over a. That is the reason it's b over a. This is the auxiliary construction. Actually, you put A, you put B, you apply the reference rectangle, you do the line for the diagonal, the corner, and this is the asymptote. And you extend it, of course, in both directions. This is a line, no segment. Now, what about in the other kind of hyperbola case when the transversal axis is on the y-axis? It's similar. The only difference is that this is A. C is here, the focus here, C. And the reference rectangle is like that. And this distance is A. And this distance is B. Therefore, the only thing that change is the equation for the asymptote is y equal plus or minus a over b x. This is when the center is in the 0,0. Si the center is no 0,0, es h, k. Entonces y minus k is equal plus or minus a over b parenthesis x minus h. End the story. Do you understand the theoretical part of the hyperbola? Do you understand the equations? Any question about that? No? Answer me. Are you there
No
here?
No questions, Professor.
Okay. Let's move to the example now. No question. Good. Let's move into the example now. The first example is super easy, you know. Always the first is easy. And little by little I complicate your life. Example 1 is, okay, is x squared over 4 minus y squared over 9 equal 1. Wow, you identify perfectly. It's a hyperbola, yes or no? It's clear the idea or no? What is the clue que help me to identification of the hyperbola? What is the clue que help me to understand the hyperbola? Remember, we have, in this moment, we have three conic sections: ellipse, parabola, and hyperbola. How you select hyperbola? What is the glue that help me to say hyperbola? What is that? Answer me. What happened, guys?
Both x and y is squared.
And?
The minus.
Exactly. X and y is square and it's minus. Okay, what kind of hyperbola we have? Horizontal or vertical? What kind of hyperbola we have? Horizontal or vertical? Or another way to ask you the question. The transversal axis is parallel or coincident with the x-axis or the y-axis? How do you know? What kind of hyperbola? Remember, you have two kinds, no? I classify, good, conic section hyperbola. But we have two. Horizontal or vertical? What's the clue of the identification? Look at the question. No? You don't remember? As I explained right now. Okay.
I don't know, Professor.
You don't know. Okay. The X part, I repeat again, please pay attention. You see that the X part is the positive part, and the positive part means que the axis of transversal o es coincidente o paralelo to the x-axis. Therefore, es horizontal. Clear? Because we have another kind. Suppose I change the problem. I change the problem like that. Y squared over 4 minus x squared over 9 equal 1. Repeat the question. What kind of the hyperbola we have in this example? In this.
So it'll be vertical?
Because y is in the equation put in the positive part of the equation. That is the reason that this hyperbola look like that, and this hyperbola look like that. Correct?
Okay, I understand now.
This is detailing, you know. Okay, we have horizontal, no? My next question, who is A square and who is B square? Who is A square and who is B square? Who is A square and who is B square?
A squared is 4.
Super. Therefore, A is 2, no? And B square 9, B is 3. Super. Now we have vertex. And by the way, I forgot the most important moment. Where is the center of this hyperbola? Where is located the center of this hyperbola? Who is H, who is K in this hyperbola? Who is H, who is K? You see some H, some K?
No.
No. Entonces, what's the idea? Center is at the point?
0, 0.
0, 0 what? The point. Something, comma, something. When you talk about point, you express the two components, X component, Y component. Center is located at the point, something.
0, 0.
0, 0. Very well. Center is coincident with the origin. Do you understand this? It's important. So you, for example, you have an equation like that. X minus 1 squared over 4 minus y plus 1 squared over 9 is 1 equal 1. No, the center is no 0, 0. Is H and K, no? Okay, by the way, in this case, H is 1 and K is negative 1. Makes sense? Completely opposite sign to the equation. Makes sense?
Yes.
Makes sense? Okay.
Yes.
Now, the vertex. Well, so you know que the center is here. Y I know also que my hyperbola look like that. This distance is 8. Okay, 2. And this is the vertex. And the vertex is located at the point 2, 0 and negative 2, 0. Make sense? In order to find the B, no, B I have C. The formula is C squared is equal to A squared plus B squared. Entonces, C alone is square root A squared plus B squared, ¿no? Es square root 4 plus 9. Es square root 13. Square root 13 and decimal approximation is 3 point something, 3.606. This is the focal distance, and the focal distance from the center is this segment. Look, the foci is located here, 3 point something. So the focal, or the focis, the plural, is 3.606, and negative 3.606, in that direction or in that direction. To finish that, you can do the asymptote. To do the asymptote is easy because we have A and B. A is that distance, and B is 3. It's a little bit bigger. A is 2, B is 3. I connected the asymptote. This is my reference triangle. No? Actually, my reference triangle look like that. This distance is 2, 2. This distance is 3, 3. And you connect in the corner, and this is the asymptote. My sketch is not good. After we are doing Desmos, fantastic. The most important thing is the asymptote equation is y equal plus or minus b, que b is 3 over 2, que es a x. We have no h, we have no k, because passing through the origin. What I declare clear que transversal axis is x-axis. This is transversal axis. This. We have another axis, but it's not important. Let's call it conjugate. It's a weird name, conjugate axis. In this case, a y. But this is not important. The important is the transversal. Another perpendicular. And that's it. So let's see in Desmos. The last time I sent to you one more time the script of the Desmos. Do you see? With the corner section. It is in the same email que I send the video of the last lecture. I send the link connected YouTube and send another link connected to Desmos. Do you see yes or no?
I have it.
Yes.
Yes.
Yeah.
Super. It's the same tool that we use every day, guys. And this you can use it in your test, like a script. Okay. Desmos. Switching to Desmos. Okay. We are doing. Do you see now? We are doing the first problem of the
Yes.
hyperbola. Hyperbola number one. This one. And this. Look, x squared over 4 minus y squared over 9 equal 1. And guys, don't hesitate. You can modify, you can make a mistake, you can delete, because this is the script you have is a copy of my script. So if you are doing something wrong, doesn't affect my work. And si you consider que something is wrong, bueno, you undo here and aquí. Or when you save, don't say no save. It's closed without save. So don't hesitate to change in your test and your homework. Okay, entonces this is the hyperbola. Boom. Look at that. But I need to determine the famous point. Entonces now, in this problem, A is 2. I change here, 2. B is 3. B is 3. And H and K both are 0. Nice, I like that. And P no, P is the parabola. Entonces, hyperbola and ellipse AB. And that's it. And what kind of hyperbola it is? Because the equation changed. Entonces, my script, I programming inside this horizontal or vertical. I classify like a horizontal bone. Wow. Look at that. You see, this is the original problem, original equation. However, when I click here, you see the famous point. This is the center in green color. This is the vertex. This is the fauces. This and this. And this is the famous four corner of the reference rectangle. Okay, not necessary to do it this way, but and this is the asymptote. Any question? Super clear, eh? Suppose?
It's clear.
Let's move on to another example. Example 2. Sorry, you see the whiteboard? Or no?
We see it.
Yes.
Okay. See, because I forgot si ya switch or no. Okay, entonces 16 y squared minus 9 x squared equal 144. Suppose in the text I put something like that. Well, professor, this is not expressed in standard form, because the standard form right hand side must be 1. And the classical equation I have in my brain of the hyperbola is y squared over a squared. This is the classic I have in my brain, no? Y squared over a squared minus x squared over b squared equal 1. Entonces, don't expect that I give you in the test something like that nice. No, I'm a guy. So I give you completely disorganized, and you immediately to analyze, you are pressing a standard. But in this case, super easy. You divide the whole thing by 145. Because I need 1 in the right-hand side. Entonces, well, 145 divided by 16 is 9 at the bottom, of course. And this is 4, no, 16, sorry. So you divide 144 divided by 9 is 16 equal. Oh, nice. Nice. I have now the equation expressed in standard. Yeah, I can working now with this. What kind of hyperbola we have? We have vertical hyperbola or horizontal hyperbola?
Vertical.
Vertical.
Ajá. Ok, entonces the famous transversal axis is coincident or parallel with the x-axis or the y-axis?
Y-axis.
Exactly. So my graphic I expect when I finish look like that. Yes or no? Boom. Correct? Correct?
Yes.
And this is the
Yes.
transversal. And this is the transversal. Boom, 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 boom. Super. Now, who is A square and who is B square? That's my next question. Tell me. Who
A
is A?
squared is 9.
Absolutely, I'm right. A
And
squared.
B squared is 16.
Therefore, is 9 and this is 16. Therefore, A alone is 3 and B alone is 4. Correct? Always positive is the distance, guy. You find the square root plus or minus, no. It's distance. You take only the positive solution. Okay, this is A, this is B. Now. I want to find, I forgot center. I don't know why I always forgot center. What is located center of this hyperbola? At what point is located center? At what point is located the center of this hyperbola? Help me to understand this. Example 2. You have problem with the center, guys? So you see que we have no
0,0.
0,0 es obvio, es 0,0. Why? Explain me why. How do you know que es 0,0? Because we have no what?
No H and no K.
Exactly, no H, no K. So our hyperbola is without transformation, only no motion to the left, to the right, or upward, downward. No shift. Entonces no H, no K, center es 0,0. Okay. Now, what about Z? The formula is C squared is equal to A squared plus B squared. A squared is 9, B squared is 16, is 25, and square root 25 is 5. Therefore, C is 5 is a focal distance. Okay, super. Now, one more. Let me try to do one roughly sketch. I don't know completely. I completed in the Desmos, no? This is X, this is Y. Center here, 0, 0. Entonces I know que my hyperbola is vertical. I know que A is 3. Okay, entonces the vertex located in the y-axis, 3 up, 3 down. Like that. 1, 2, 3. This point is the point 0, 3. This is my first vertex, vertex 1. And my second down, 0, -3, vertex 2. And my hyperbola look like that, open in that direction, I guess so, no? Like that. Complementary idea to finish the graph. Focal distance here, and 5, 4, 5 here, 0,5 and 0,5. That distance, -5, sorry. That distance is 5, guys. Right? -5. This is -5. And what about B? Well, B is 4, but I don't care too much B, because the only thing is useful for B is to make the asymptote, no? This is A, this is B, is 4, that distance is 4, look. That distance is also 4, that distance is also 4, and that distance is also 4. So our famous reference rectangle is formed, the center is in the origin, of course. And you compare A here gets 3 in our example, and B here gets 4. And B actually is 8. The dimension for this rectangle is 8 and 6, no? And we're connecting. Are we connecting? We're connecting the corner by the segment dotted line, and you extended the asymptote. It's obvious that the hyperbolic I'm doing at the beginning is a mess. It's crazy. It's not like that, never. But it's roughly sketch. No? We're doing accuracy in Desmos, and in the test you print out the Desmos version, no? For me, 0.3. Actually, suppose que my hyperbola is like that. Approach pero never touch. Approach pero never touch. Approach pero never touch. Approach pero never touch. Remember vertex, focus, forces, this and this. And what about the equation of the asymptote? Well, the equation is y is equal plus or minus 8, que 3, or bigger 4x. No, this is the equation for the both asymptote. Well, positive is this. This is y equal 3 over 4x. And this is this. Y equal minus 3 over 4x. Wow, fantastic. I like that. It's super easy or no? The thing is that you need to remember the rule. Remember the parameters, remember the formulas, remember definitions, transversal axis, in what direction open, the hyperbola. And this together is confusing. Ellipse, parabola, hyperbola. So you need to integrate this in your brain. You are an advanced student. You are not kindergarten students. Right? So you need to try to find a way to memorize this information. Let's move into Desmos. To see more, accuracy. This graphic look like crazy. Okay. Desmos. You see? This is example number 2, no? Yeah. Hyperbola number 2. Look, I copy exactly the same. I copy identical. I don't change the original. Wow, hyperbola. Vertical hyperbola. So now to find the point, the script help me. How help me? You go back here to the slider and you put AS3, no? AS3. And BS4. 4? 4. BS4. And H and K is 0. Yeah, I don't care P. P is not important. Yeah, P is important only in the parabola. So now I select what kind of hyperbola we have. Is horizontal, no? Horizontal hyperbola, no vertical, no? Vertical hyperbola, sorry. Boom, look at that. Center 0.0. Vertex 0.3, 0.-3. Foci 0.5, 0.-5. And the famous four corner, the reference rectangle and the connection with the asymptote. The story. Any question? No question? No? Well,
No questions.
Okay.
No.
Let's move on to example 3, more complicated. because in the example 3 we have a center no 0, 0. We have another point. Example 3. Okay, it's x minus 2 squared over 9 minus y minus 3 squared over nothing. I don't know what happened here, equal 1. Okay. First question. What kind of hyperbola we have? We have horizontal or vertical? The thing I try to ask is, this is this kind or this kind? Horizontal or vertical?
Horizontal.
Very well. Next question. Where is located the center of this hyperbola? At what point? How you find the center? What is the clue to find the center? H and K, no?
2,3.
2,3. Very well. And this is confusing for some students. Okay, the sign of the point is completely different to the sign of the equation. No? So you see negative because the point is positive. So you see positive is because. Do you understand why? Or no? Do you understand what is the reason it's opposite sign? Yes or no?
Yes.
Okay. Next question. Who is A squared and B squared? Who is A squared? Who is B squared? How you identification who is A squared and who is B squared?
9 and 1.
9 and 1. Very, very well. 9 and here is invisible. I suppose que 1. Therefore, A 3 and B is 1 again because the square root 1 is 1. What about Z? It's the focal distance. It's A squared plus B squared. C is the square roots A squared plus B squared. It's square root 9. 3 squared is 9 plus 1 squared is 1 is radical 10. And radical 10 is a irrational number. You compute the decimal approximation that is 3.162. 3 decimal place, like a Desmos. Okay. So identification, let me try to do a roughly sketch. Not completely because it's crazy completed. But approximately. Okay, I know que my hyperbola, you determine que es horizontal, no? Horizontal, right?
Yes.
Yeah. Hyperbola. Okay. And the center is 2,3. 2, 1, 2, 3. This is X, this is Y. This is center. Si horizontal is because the transversal axis look like that. Yes or no? So the transversal axis equation is horizontal line, y equal 3. Make sense? So see somebody asks you, what is the transversal axis? Bueno, es the horizontal line at y equal 3. What is the conjugate axis? Bueno, es perpendicular. It's at x equal to, que es this guy. Okay. So now the vertex is located a distance from the center and to the right and to the left direction. So 3 distance is 1, 2, 3 is 5. 5. 5, 5, 5. 5. 5,3. And the other direction is 2 minus 5, no? Minus 3, minus 3. 3 is negative 1. It's negative 1. Okay, that point, get the vertex 1 would be 5,3. And this point, get the vertex 2 is negative 1,3. You follow me or no? Do you understand where I come from this? So I suppose use my imagination is this is a wait. This is a segment, and this is a segment in another direction. And what about B? B is 1. Entonces B is 1. Entonces 1 que es B in this direction. I determine one corner of the reference. I'm going to corner here. One corner here. This is big as 1. B1, B1, B1. Entonces my famous asymptote is like that. It's a 1 and it's a 2. Then the rest using my common sense. Our hyperbola, let me use the blue color. Look like that. Look, starting vertex is asymptotically here and here. Starting vertex is asymptotic here and here. Okay, one more information. Fuzzy. No, fuzzy is weird because this number is crazy. But it's the same stupid idea. You moving C distance. Here, I suppose a decimal number here. I suppose a decimal number here. You see in decimal now. This is the fuzzy. Focal 1, focal 2. And the most important is the equation of the asymptote. Que es y minus k, que k es 3, ¿no? K es 3. Is equal, plus or minus, b over a, b is one third, b over 3. Paréntesis, x minus 2, ¿no? Que es h. I don't know if you remember when we studied intermediate algebra, the equation of the line, this is y minus y1 is equal as log x minus x1. And this 4 is called a point slope. Point slope 4. We have another que es y equal mx plus b, que es slope in a set form. And we have another que es standard. Entonces, now the style in this part, I don't know, in the book, using point slope. Because it's easy, no necessarily distribute the property, isolate the y, no, leave it like that, it's perfect. Any question? I do roughly sketch by hand. No complicate my life because I finish in Desmos. And using the script created for me, okay, and your teacher. Okay, any question before I go to the Desmos? No?
No questions.
No. Let's move on to Desmos. Okay, I'm okay. Okay, I suppose you see Desmos, right? Nothing here and nothing here. Okay, example 3. Check this example. Look. Well, I make some mistake. And hello. Well, okay, I can change, you know? Yeah, I can change. I can change. And the example I put in the whiteboard, this is a negative, right? Doesn't matter. You can change. Look, this is perfect table to any condition. Okay, entonces I discover in this example que A3, B1, H es 2, and K es 3. No negative, no positive. Es 3. Entonces I classify this hyperbola like horizontal, no? Horizontal. Oh. Wow, too complicated. No, pero no. Let me make it soon. Center 2,3, vertex 5,3, negative 1,3. And the focus is close, very close to the vertex, because the centricity of this hyperbola is a little bit flat. And the equation, this is the corner of the reference rectangle. Do you see perfectly, guy? You see when you open that, please don't change the mathematical behind this. This is the most important part. The mathematical behind this. It's no big deal, but I create. So you destroy this mathematical, just, well, don't save. Clear?
Clear.
Yes.
Let's move on to the last example of the hyperbola. Whiteboard. Do you see whiteboard? You see, right?
Yes.
Example 4. Example 4 sound weird. No, it's okay. Look. 11 x squared minus 2y squared plus 66 x minus 4y plus 75 equal to 0. Don't be scared when you see something like that, because the thing is that you need to apply some algebra to organize this in the standard form of the hyperbola. And so when you have a standard, you see clear what is the center, what is A, what is B, everything. So now it's obvious that you have to complete the square. Complete the square, complete the square. And you group in the x and the x. You copy. 11 x squared plus 66x. I need to do something to complete the square, the x part. Pero no. Before that, I factor out 11. I factor out 11. So I need coefficients no 11, sino coefficients 1. So I write like that. Look. 11 parentheses x squared plus 6x, because 6 times 11 is 66, plus box. Okay, it's the number that we need to complete the square. After we dedicate that, you don't worry for this. Now, likewise, in the y part, we're doing similar idea. In the y part, for example, I grouping somehow this guy and this guy. Entonces es negative. Es negative something, negative something, negative 2. Where's the greatest common factor between 2 and 4 is 2. And so we have y squared plus 4y plus box. No, 4 box, 2. Because the coefficient original is 4. You factor out 2, stay 2. So this is not 4, it's 2. So now the famous number that completes the square, Remember, in the standard form of the hyperbola, we have 1. I need 1. So I move 75 subtracting plus 2 boxes. It represents the number that you introduce artificially inside the complete square parenthesis. And the first number is 6. You take b, que es 6, divided by 2 square. 6 divided by 2 is 3, square is 9. This is the 9. And this 9, when you introduce artificially this 9 inside the equation, actually, this 9 represents, in the right-hand side, 99. Why 99? Because this 9 multiplied by 11, que es a factor outside, is 99. Here is similar. 2 divided by 2 is 1, square is 1. So the magic number that we need here is 1. Actually, this is no 1, is negative 2. Do you see very well this idea or not? Yes or no? Now, factorization. This is trinomial. This is another trinomial, but it's special, no? Because I create artificially. I create perfect square trinomial. And the perfect square trinomial, the factorization is only one binomial, que es x plus 3 squared. Minus 2, y plus 1 squared. And you combine this guy, this is 22. 22 post. Yeah. No. I think no. Remember the standard, I need 1 here. So you divide by 21. By 22, sorry. And 22 divided by 11 is 2. Minus y plus 1. And 22 divided by 2 is 11. Equal 1. Fantastic. This new equation is now expressed in the very well-known standard form of the hyperbola, and by the way, is equivalent 100% algebraically speaking with the original ugly. Can nobody understand? Now you need to determine clear where is located the center of this hyperbola. Where is located the center of this hyperbola?
-3, -1.
Exactly. -3, -1. Very well. It's h and k with the opposite side. And this hyperbola is horizontal or vertical? So this hyperbola open in that direction or in that direction? Horizontal, vertical.
Horizontal.
How do you know horizontal? What is the clue that give me information the horizontal?
Because the x is positive.
Exactly, because the x is positive. Okay. What about a square and b square? Who is a square? Who is a square? Who is a square? Who is a square? And who is b square? In this equation. Remember, we compare to this. X minus h squared divided by a squared minus y minus k squared over b squared equal 1. No? This and this is the same thing. This is a particular example. This is general. This is so big, a squared 2, no? And b squared is 11. Okay, it's a weird number, but it's the answer, right? Because a is square root 2. And the decimal approximation is 1.414, and b is square root 11. Both are prime number. It's a rational number. And you get decimal approximation is 3.316. That is the reason that the computation of the rest is complicated, no? Point by point, because involve decimal. That is the reason that you are doing using the Desmos. But finally, let me try to find the equation of the asymptote. Okay, the equation of the asymptote, remember, is y minus h minus k, sorry, is equal plus or minus b over a, because it's horizontal, x minus h. Y minus k, k is -1. This is h, and this is k. This is plus 1. Is equal plus or minus, and b is radical 11 over radical 2, no? Is a. X plus h is 3. It's weird, but it's you can write like that if you want, plus or minus radical 11 over 2 x plus 3. Okay, let's see in Desmos. And Desmos is a little bit, let me show you, a little bit complicated because it's irrational number, no? But it's okay. It's okay. Let's do it. There you go. Desmos. Do you see? Example number 4. Which, let me erase everything. And this. Okay. Let me set out. A was radical 2. So to put radical 2, we're using the Desmos keyboard. And you put radical 2. And click outside. So you press enter, no, because change the line to say, give me a gap or hole. And B radical 11. So you put radical 11 and click outside. Super. What about H and K? We say H was K. Well. H is -3. H is -3. And K is -1. No? I am doing well, guys. I don't remember very well the number and the board. I did well. Let me see the last example. The last example is always horizontal. Look, hyperbola. Entonces, horizontal, ¿no? Horizontal hyperbola. Okay, recap. Center, -3, -1. And the rest is we are decimal because it's irrational number. No? This is vertex and the asymptote. Wow, fantastic. You see the advantage to using this application? Because without this application, you avoid the arithmetic of the decimal number. Any questions so far? I promise in the review package, we go over again to this. Solving, of course, complicated problems similar to the test. And the test, you see, it's example similar to the example 4, no? No, like example 1. Example 1 is introduction, no? Elementary. Okay, next section. Let me try to cover something about next section. Is about sequences. Sequence. This is easy. Sequences. What is that? Sequence, you can interpret it like a function. But the domain, the function. But the domain of that function is a natural number. What means natural number? 1, 2, 3, 4, 5. Infinity. No zero, no negative. No 1.5, no radical 2, no. 2 real number. And that function is expressed in the mathematical formula, no? And normally the notation we are using is like that. Suppose A sub m. This is the
Professor,
x.
we don't see the whiteboard.
Sorry, carajo. Now, yes?
Yes.
Okay, the thing I tried to explain was the name of the topic and next topic is sequences. And sequence is easy. In my opinion, is the easy way to this subject. As you understand, it's a function, but the domain of the function is a natural number. So as you call n equal 1, 2, 3, 4, 5. No negative, no fraction, no decimal, no irrational. And the answer, no. The answer depends on the mathematical formula for the sequence. And normally, the sequence is expressed in this. Look, let me show you. You open this curly bracket. You copy the mathematical expression here, 1 over m. And some book put for n equal 1 to infinity. N approaches to infinity. But default, si no definition this, you suppose que es 1 over n, and that's it. You suppose que the first number is 1, and the last one, is continued forever to infinity. So, for example, one typical question say, determine the 5 first number of the sequence. Okay, it's A1, 1 over 1, que es 1. A2, 1 over 2, que es 1/2. N equal 3 is 1/3, and so on. 1/3. A equal 4 is 1 over 1, 2, 3, 4, and 5. 1/5. You can indicate the answer like that. Open this 1, 1/2, 1/3, 1 over 4, 1 over 5. Because you want to find the first element in the sequence. Okay, this is symbolic way. And this is another symbolic way. Okay, this is called explicit formula. Because we have another formula. Que es no explicit, es recursive formula. Explicit A sub m formula for that sequence. In this specific example, and by the way, this is the example 1. Let me try another example. It's just plugging in, guy. Well, so far. Example 2 is A sub m. Explicit formula is n minus 1 over m. Okay, some book enclosed in the curly bracket, some book no. So you need to find the first element. Entonces, I need to find A1, I need to find A2, I need to find A3, A4, and A5. Substitution, we suppose to start for 1. 1 minus 1 is 0. 0 divided by any number is 0. A2 is 1 over 2. A3 is 2 over 3. It's logical because the bottom number, the denominator, is exactly the same with the index, que es m, and the other is minus 1. So this is A4 divided by 4. 4 divided by 3. 4 divided by 3 divided by 4. And this is 4 divided by 5. So the answer is 0, 1/2, 2/3, 3/4, 3/4, 4/5. I stop here because they want 5 elements. Only find the first 5 elements. Is it clear? Example 2. Okay, one more and that's it, because I don't want to complicate today. This is interesting, very interesting, because the formula is using the curly bracket or no, -1 m plus 1 2/3. 2/3, no, 2 over n, sorry. This is the formula. So the formula includes -1 n plus 1 times 2 over n. Entonces you have n1, n2, n3, n4, n5. N1 is plugging in 1 here. Okay. Listen to me. This is important. -1 and the exponent is 2 because it's 1 plus 1 is 2 and 2 over 1, right? So A1 is 2 because -1 squared is positive. It's important that you see the effect. This term, -1 to the what is the effect of this? So we have -1 raised to the third power because remember the exponent is 1 unit more than the index. The index is 2 and 2 plus 1 is 3. 2 over 3. It's obvious that A2 is negative because -1 raised to the third power is equivalent to say multiplication -1 times -1 times -1. We have 3 negative and the answer is negative, no? -2. Wow, entonces what is the effect of this? It's alternating sign. One element is positive, another element is negative, and the next we expect que es positive, negative, positive, negative, positive, negative. Entonces in this case, what is the negative and what is the positive? One of the even index is negative and the odd is positive. But this is the case in which you have this situation. Suppose you have -1 to the m, no plus 1. Entonces completely different. The even is the positive and the odd is the negative. Make sense? A3 is positive, 2/3. A4 is negative, 1/2. Because 2 over 4 will reduce the lowest term. And A5 is positive, 2 over 5. Entonces now the sequence, let me write the sequence of the 5 first term of this sequence is 2, negative 2/3, positive, positive. By the way, I make a mistake, no? Yeah, of course, absolutely, I make a mistake. This is 2 over 2. This is 2 over 2. This is 2 over 2, and 2 over 2 is 1. This is negative 1. This guy is negative 1. So the sequence is 2, -1, 2/3 positive, -1/2, 2/5. Let's stop here because we have 1, 2, 3, 4, and 5. Do you see the idea? Do you understand the idea? Of course, I want to complicate more this. We have more possibility, theorem, etc. In particular cases. But this is the idea, sequence of the next topic. We almost finished the semester, guys. We almost finished the semester. After the sequences, we have the mathematical induction. No, sequence, complete sequences. This is introduction topic. After we have the geometric and arithmetic sequence. It's one of this particular case of the sequence. Problem, interesting problem with this. Mathematical induction is a little bit weird. And binomial theorem. And that's it. You are ready to take calculus. You took trigonometric also or no? I know that some students take with me trigonometry, but the majority of you took trigonometry or not yet? Answer me.
I haven't.
You took, no?
No,
Not
I
yet.
haven't taken it.
When? In the summer. In the summer is crazy, guy. Well, no, I don't know. Trigonometry is hard than pre-calculus because you need to memorize a lot of information. And some people have no mental organization for this. But your goal is take calculus 1 and calculus 2, no? Yes or no? Or no? Or you finish with this?
Yes.
What mean yes?
I need to take the calculus 1 and 2.
Aye. Okay, what is your major, miss?
Computer engineer.
Absolutely, yeah. And after you take discrete mathematics. Okay, okay. And no, there are no students here que the major is engineer? No? No
I'm doing
engineer?
information technology. So next class I take is discrete math.
And that's it?
Think so.
Oh, good for you. No calculus?
No.
Okay. And no engineer, nobody engineer? Because engineers need to take calculus 3 also. You know? Okay, guys, too much. We continue next week. Okay, have a nice, good day for everyone. Bye-bye.
Thank you, Professor.
Mm-hmm.